Welcome to the Cisco Netacad CCNA Introduction to Networks video series by Jason Johnson. This video is Chapter 7, IP Addressing. The material in this video covers the 6.0 version of the Cisco Netacad CCNA Introduction to Networks course. I want to thank you for watching these videos. Your time is appreciated. And if you find this material helpful, you can subscribe to my channel. And remember to click the notification button below if you want to see when I post new content. If you have any questions, you can leave a comment below. And if you watch to the end of the video, I'll have links to the next chapter. So let's talk about Chapter 7, IP addressing. In Chapter 7, we're going to look at the V4 or IPv4 network address. We're going to briefly look at the concept of binary versus decimal, the structure of the IPv4 address, characteristics, the V6 network addresses. And again, if you've been watching my videos, you know I just refer this to V4 and this to V6. We're going to look at unicast addresses in V6, multicast addresses. We're also going to look at connectivity verification with ICMP. So let's move ahead and let's talk about V4 network addresses first. On the V4 addresses, what I'm not going to do in this video is go through the whole how-to of converting binary to decimal and decimal to binary and subnetting and all of that. I've got separate videos for that. Check in the description below, or you can check on this playlist at the end. I put those videos at the very end for you, and we'll talk about how to do that conversion. What I will just talk about real quick is let's talk about V4 addresses and the concept of it. So a V4 address consists of a string of 32 bits, not bytes, bits, divided into 4 sections called octets. So you'll hear the term octet. Well, an octet is 8 bits right there. So you have 8 bits, 8 bits, 8 bits, 8 bits, and that makes up 32 total. So each octet contains 8 bits or 1 byte of information. So 1 byte, and so forth, separated with the dotted decimal. That's why or with the decimal in the middle, and that's why they call it dotted decimal. You might hear someone call it that way as well. This is dotted decimal right here, because this is decimal with the dots in the middle. This is binary, of it converted to binary. So it's saying 192.16.10.10. If you've been working with networking or you've seen IP addresses before and you see something like a 192.168.10.10, you'll know that that's a dotted decimal here, and you can convert that to binary. And it's 4 octets of 8 bits each. Now, when we convert binary to decimal, there are lots of videos on the internet or out on YouTube. There's all kinds of ways to convert, different ways to show you how to convert binary to decimal. If you watch my videos, again, in the description of this video, I show you my way. There's other ways to do it in the Cisco Netacad material for this course. Underneath Chapter 7, you're going to have some material in there that also shows you how to convert that. So what you want to do and what you're going to need to know how to do is convert decimal to binary, binary to decimal, at least up to the 8th place of binary. And you're going to need to know how to do that without a calculator. I'm just going to let you know you need to learn how to do that. So that just as a tip of a study tip, you want to learn how to do that. So when we're talking about, let's move over to the structure and why we set it up the way we do. When one of the bits of confusion that I had when I first started studying networks was the difference between a network portion and the host portion. When it finally clicked for me was when someone described and said, as that packet of information or as these ones and zeros are being read by the computer. So let's just look at the concept of we're taking one computer and we're sending a string of bits, ones and zeros from one computer to another. And we're sending those across medium over to this computer over here. Well, when we send those, we have that packet or we have that encapsulated numbers that go through. Well, as they go through, the computer has to be able to read those. And when it reads, for example, an IPv4 address, it knows when it gets to a certain point in that string of ones and zeros, it says, okay, here's the host destination here, or here's the host IP, here's the destination, and here's what it should be. Well, as it starts reading these numbers, ones and zeros, depending upon the subnet mask, depending upon these numbers here, and these subnet mask is going to be a string of ones. Once it gets to a 0, it's going to say whatever comes after that last one, since this is a 0 here, whatever comes after that is the host portion. Anything to the right of the last one is in the host portion, and the host portion just means in the that local area network. That's the way I remember it. That's your LAN portion over here. You'll hear everybody say host portion, but it always clicks with me when I say that's my LAN portion. That everything on this side right here can see each other. Everything on that side is in a separate network. So when the computer is reading those ones and zeros, it says, okay, all of this network portion right here is separate, or that's your network portion, that's your network ID, and this is your host ID, or these are your host portion. When it says portion, those are the segments of it. So if you change anything over here, so if this is 192.168.11, so .11 will not be able to see anything over here from .10. So when you change that, so if these are all the same on the network side, then it doesn't matter what this number is over here. They can see each other. They're all on the same LAN. So hopefully that makes a little bit of sense to you on that. So when we look at the prefix link, you want to look up in your reading for this Netacad course, what's the network address for graphics, what's the prefix links for graphics, and look those up for logical and prefix links. That's going to be in your reading. So check those out. When we talk about network host and broadcast addresses, a network address is going to be this address right here. So 192.168.10. It doesn't matter what's over here. Usually you're going to see it represented by a 0. And if you say 192.168.10.0 is your network address, you know that everything past .10 or 10. Whatever over here is on, everything over here is your network. Your range of valid hosts are going to be everything from here, so 0 to 255. Now, there's some things you need to know though as far as network ID and broadcast ID, and these are things that you just need to get. This is your network ID or network address over here, so 192.168.10. So if we have 192.168, I can't write. I'm trying to write with my mouse. .10 and .0. This is your network ID. 0 is your network ID. It's always your first number in that host range, the first number in your host range. And 255 in this case is your broadcast address. So your last number is your broadcast address. Your first one is your network. So just so you get that concept down, and you'll get that in your reading as you go through the material for Chapter 7. It'll show you that. I'm just kind of reiterating that in the presentation here. So your valid range of host is 1 to 254. So whenever you do a range of host over here, now I'm going to do a video on subnetting. I've got a separate video on subnetting, and I talk about network ID, broadcast ID, and valid host. And I'm gonna go into that in much more detail, or I do in my other video. I'm just wanting you to understand that your network ID is your first one, your last one is your broadcast, and everything in between is your valid host. What you have to remember though is as you start subnetting, it may or may not be 0, because this is where some people get confused. It's not always 0 though, because you can have if I split this up into 2 subnets, 0 is still my valid for this network address. But if I split that up and say I'm going to subnet that and say now 92.92 is my new network address, because I've got that split into further subnets here, then if I subnet over into here, that network ID and that broadcast ID will be different than 0 and 255. So just make sure that you understand that when you start subnetting, those are going to be different. But when we're talking about this simple way right here, when we're talking about a /24 or a 255, your network ID is 0, your broadcast ID is 255. Okay, so when we talk about unicast, broadcast, and multicast, in a previous video I talked about what those different ones are. A unicast goes to let's back up. So IPv4 addressing assignment to a host. So let's talk about this first, and then we'll talk about the unicast broadcast. I got ahead of myself here. So a static IP address, you type that in manually, and you're going to go in and you're going to type in something like let's just stay here. We type in 172.16.4.1, and we have to go into each machine and type those in. I used to do that back in the early days when I was first working with networks back in 1997, 1998. And I had a spreadsheet that I had to have all the host IDs, have the computers, I have all their IP addresses, and I had to go and assign them to each computer. And if I messed up, I would have to then go back and I would be putting in it. I might have messed up, and it said, oh, this IP address is already on the network, and I would then have to backtrack and figure out which computer had which IP address, and it was a pain. Well, then they've come along with Dynamic Host Configuration Protocol, DHCP, and you've probably heard that term DHCP. It stands for Dynamic Host Configuration Protocol. You do need to know this. That is going to be on exams. So your DHCP, though, it is a service that sets either on a router or on a server. It's set somewhere in your network, or hopefully it does, and it assigns IP addresses. And you set your DHCP server up to say, I want these range of numbers to be able to pass out, to be passed out. So in this case right here, we're passing out 172.16.4.1 up through 250, probably 254. So computers inside that range of that DHCP are going to be able to get that IP address assigned to them. And hopefully that'll make sense for you, that those get assigned automatically by the DHCP. Now, when we talk about communication on the V4, you have unicast, and that sends packets from one host to an individual host. Unicast meaning one, uni meaning one. And this is a unicast right here. You have one host and you have one destination, and it sends that packet through the switch and down that way, and that's a unicast. A broadcast. And this is how I always remember it. Uni is one. Broad means it's a broad-based. Means it sends packet from one host to all the hosts in the network. And I just think of broad being like throwing out, a broadcast, or being a big broad area. So that's how I remember it in my head, broad, which means that it's going to go from one all to all the rest of them. This is a broadcast up here. And I should have put these in order, but I didn't. So this is a broadcast here. It goes out to all of them. Boop, 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 boop. And then you have multicast. Multicast, and I always think of multicast is it's going to send to multiple units, but not all units, or not all endpoints. So it's going to send a packet from one host to a selected group of hosts in the same or different network. And that's what would be a multicast down here. So you have one node sending out, and it don't send it to here because that don't pick it up, but it sends it here and here, but not there. And that's multicast. So based on these, I just ask you a question. Which type of communications are the graphics on the right? And that's multicast, unicast, and broadcast. Okay, so we have different types of V4 addresses. We used to call them classes, but we pretty much just say that we have classless classless addressing now. What happens is we have public and private IPv4 addresses. So private addresses are not routed on the internet. So if you have anything in this range here, 10.0.0.0 or 10.0.0.0 to 10.255.255.255, this range or this range, it's not going to get out onto the internet. It just won't work because routers will not pass those numbers through. Those are considered private addressing. You can use those ranges of addresses in your local area networks. And so whether I typically go, a lot of people go with the 192.168 range. That's one that gets used a lot because it's a /16, and it gets used in or you can use it as a /24, all the way up into the 24/24 range. And again, if you're not sure what the /8, 12, 16 is, I've got videos on those. You'll hear it again just in the description below. So those are private addresses. You cannot route those on the internet. You have special user V4 addresses. Your loopback address is your 127.0.0.0. That's assigned to your NIC card, or 127.0.0.1 all the way up to 255. But if you're using your ping command and you ping 127.0.0.0, you should get a response back from your NIC card. If you don't get a response back from your NIC card, then something's wrong with your NIC. You have link local addresses, or what we call APIPA, I call it APIPA, automatic private IP addressing. That's assigned by the computer automatically if it doesn't pick up a DHCP address, and if it doesn't have a manual address put in there, it will assign one automatically in this range right here, 169.254.0.1 or up to the 255.254. So if you open up your IP address and you look at that and it's got this 169, or you ping your local and you say, hey, what's my IP address? And it's 169 range in that area there, you're going to know that your Windows machine automatically assigned that to you. Then you have your testnet, which is 192.0.2.0. all the way up. Now, when we talk about, let's switch gears here to what I talked about, classless addressing. You're going to probably see questions. You're probably going to still see some material on Class A, Class B, Class C, Class D, and Class E. we really don't, I personally don't teach the classes anymore because we pretty much do classless addressing, and that's the CIDR addressing. We use the slash at the end to say where does that IP address fall in the range from 0000 all the way up to 255, 255, 255, 255. That we use CIDR addressing. So we allocate v4 addresses based on prefix link, and that's our, the slash. So a slash 24 means we have a subnet of 255, 255, 255 because we have 24 bits being used as the subnet mask. So, and again, my videos on subnetting will cover that a lot more. So let's, oops, I got that there. I need to, there we go. So let's take a look at V6 network addresses now. V6 addresses can be daunting to people that are coming into them new because they are so large. The reason we have V6 addresses, and you may be asking yourself, where did V5 go? Well, they skipped V5. They went from V4 to V6. I'm really not going to cover it in the scope of this presentation here, but you can go out and research it on the internet on what happened to IPv5. It didn't just disappear. Something did happen to it, but I'm not going to talk about it here. But what happened was we ran out of V4 address space. We just did not have enough IP addressing. V4 was created many years ago. So in 95, if I'm correct, I may be wrong on that, but I think 1995 was when V6 was put into play, when it was finally approved. So it's been around for a long time. And you'll hear the term Internet of Everything. The reason you hear the Internet of Everything is because V6 addressing is such a large number. I mean, and it's really hard to get your mind and grasp around it. And when you read your material in the Cisco course in Chapter 7, you're going to read about the size of it and the scope of it. But it's so large that we really could assign IP addresses to pretty much everything, to every phone, to every watch, refrigerators, toasters, microwaves, everything can get an IP address because there is such a large address space. Now, because we are moving from V4 to V6, it's taking a long time. They are coexisting together. So the V4 addressing is built into the V6. So when you have a V6 address, you can usually find the V4 in there. So when you hear the term dual stack, that just means that V4 and V6 can be on the same network. So if you hear of a dual stack network, it just means that that you have, and let's go over here to the right hand side. So we have a dual stack over here. So it's running both V4 and V6 on a dual stack. When you hear the term tunneling, that means that V6 packets are put inside V4 packets. That means that you have a V4 only network still. They're still out there. Yes, there are still networks that only run V4. So what happens is the dual stack router goes ahead and converts that V6 address into V4 packets. So it breaks it down into smaller packets, runs it through the V4 network, and then uncompresses it over here or unencapsulates it, so that it can run on the V6 only network. And remember that even though it says V6 only, V4 is built inside of V6. So even though it says V6 only, it's got the V4 information built inside of it. And then when we talk about translation, you have a V6 packet, it's translated to a V4 packet and vice versa. That's a NAT64 router that translates. So if I have a V6 only and a V4 over here, and again, I'm going to say, when it says V6 only, V4 is embedded inside of V6. The information is embedded inside there. So when it says V6 only, it'll run V6, and that's it'll have the V4 information there. But when you have a V4 only, it does not know the V6 information. So you have to have a router that converts that information. So let's take now a look at V6 addressing. When we look at V6 addressing, and some of the terms you need to know with this is there are some rules to writing out a V6 address. It's written in hexadecimal. I do not have a video on converting hexadecimal to binary and to decimal, but there's information in the Netacad course to help you with that, and I needed to get a video done. But there are rules though for writing out a V6 address. Now, the different rules are you can omit leading zeros. So when I have a V6 address, it says 0000. See, I have that hextet right there, and it's called a hextet. When I have that right there, I can just write that as a 0. So I can have 00000000. As long as I put the colons in between there, I know that is actually 4 zeros. So I can omit leading zeros. So for example, right here, I can call this one 2001:. DB8 colon 0 colon 1133. So you notice, see how I eliminated the 0 there and the 3 leading zeros there. And you can also omit all 0 segments, or you can omit 0 segments. So like those 3 right there, I can omit those altogether. I can also omit different segments here as long as they are contiguous or beside each other. So for example, I'm going to use this one right here. So I could technically write this as FF02 colon colon 0001. Or actually, I could write it as FF02 colon colon 1. So I could write that as FF02 colon colon 1. Now, I know based upon V6 addressing rules that I have to have 1, 2, 3, 4, 5, 6, 7, 8 hextets. Let me see if I can spell this out here for you. Hextet. If I'm spelling that right. I think I'm spelling that right. Hextet. So I know based on this right here on the rules that I have I have 2 hextets showing. So I have 6 more. 1, 2, 3, 4, 5, 6 of zeros in there because I have the colon colon. Now I cannot do this. I cannot eliminate, if these were all zeros here, I could not eliminate these and then these over here. And then just leave those. You cannot eliminate zeros if they are not beside each other. So that's the other rule on that. They have to be beside each other. Now, when we talk about the different types of V6 addresses, we also have unicast, multicast, and anycast. Ooh, that's a little bit different. We don't have unicast, or we have unicast, multicast, and broadcast, but we don't have broadcast anymore. We have anycast. So when we look at the breakdown, we have 64 bits on one side and 64 bits on the other side. This is the prefix, and this is the interface ID. If you remember back to the V4 where we had the network portion and the host portion, you can kind of think of it as the same way here. Prefix on this side and then interface ID on that side. And when we have our unicast or our unicast addresses, we have our global unicast, you have a link local address, your loopback, which is colon colon 1, which would be all zeros, and then the last one is 1, slash 128. Now the slash lets us know that that is 128 places, or that the interface ID is 128. Unspecified address is colon colon, and then unique local is FCC0 colon colon slash 7 through FDFF colon colon slash 7. And then you have embedded IPv4 and the V6 unicast address as well. So you have the V4 address, your octets, those are built inside those numbers. They're just converted to hexadecimal. So the prefix length indicates the network portion. So it indicates the network portion. The prefix range is from 0 to 128, and the typical length is /64. The typical length is /64. Whoops, /64. That's the typical length right there for your interface ID. Now, common types of V6 addresses, you have your unicast address, which is unique. It's internet routable. And by internet routable, what I mean is, in what you're probably used to now is, let's say that I have a computer and I've got 192.168.10.1 on it. Well, that 192 is not routable out to the internet. Well, the unicast addresses, if I'm assigned it to an endpoint, it is routable out to the internet. So I don't have to convert that. I don't have to do any type of conversion at a router. I just forward that IP address on. I don't have to have any network address translation. It's configured statically or assigned dynamically by a DHCP server. That's unicast addresses. They're unique. Link local unicast addresses communicate with other V6 enabled devices on the same link within the same network. The device creates its own link local address without DHCP server, so it just goes ahead and creates it. And if there's a conflict, it'll change it. And then unique local addresses are unique. You have the unique local unicast, if I can say that right. It's used for local addresses within a site or between a limited number of sites. So kind of think of that as your private addressing down there, unique local addresses. If you have that concept of local private addresses, or that range, that 10 dot range, that 192 range, that's your private addressing. Well, think of this as your private addressing here, but that's your unique local addresses. Now, with the structure of a v6 global unicast address, you have your global routing prefix, you have your subnet ID, and an interface ID. And subnetting allows you to then subnet that out so you can have local LANs that don't see each other. You have a static configuration of a global unicast address. That's the v6, and this is on a router on here. We're looking at the router here. So you put the static configuration into your router. So you have your v6 address, and then you put your address and your prefix link. So it'll look something like this over here. So you'll go your config.t, you'll configure your interface gigabit Ethernet is what we're doing right there, is your command. And then you're going to do IPv6 space address space, and then you're going to type in your v6 address. Now remember, we're omitting some zeros in here. So 1, 2, 3, 4, 5, 6, 7, 8. So you know you have 3 more hextets in there. So 3 more sets of zeros. But the router knows that you've eliminated those 3 by just putting : : and we're saying /64. That's the length of our interface ID, or that's the length of the difference between the prefix and the interface ID. Now on dynamic configuration, you have Slack and DHCP v6, depending on how you set those up. But DHCP v6 is a DHCP server that assigns those addresses. We also have another term called link local addresses. Those are dynamic or static, and those are link local address. And then you can verify the v6 address configuration on your router. You can do show IPv6 interface brief, and that will show you what v6 addresses have been assigned to that router for the interfaces. When we assign v6 multicast addresses, your v6 multicast address must have the prefix of FF00::/8. That is a multicast address. So an FF02::1, it means all nodes on a multicast, and FF02::2 means all routers on a multicast address. So that is broadcast out to all devices on that subnet. And then you have solicited node v6 multicast addresses. Those are solicited. So that's when they say, it's sending it out here, and it says my Ethernet NIC determined this multicast is not for me. Boop, and it drops it, and it says not for me. And then this Ethernet NIC says, oh, this one's for me. I'm going to go ahead and accept it. That would be a solicited node. All right. So let's talk about connectivity verification next. And connection verification, we can verify connections on a network. You have ICMP v4 and ICMP v6. That gives you your host confirmation, and also lets you know your destination or service unreachable. It'll give you your time exceeded and your router to redirection. So this node says, hey, is H2 reachable? It says H2 reachable, so it'll send it. It doesn't know anything about this router or any of these switches or anything, but it'll send it, and it will say, okay, yeah, I'm here, you can see me, and then you'll get a return back. So the ICMP v6 router solicitation and advertisement messages you get, and what I mean by solicitation and advertisement, it will solicit, it'll say, between v6 routers and a v6 device, they will talk to each other, and you'll get a router solicitation message, and you'll see it if you ever do Wireshark, which you will do in this course, the Netacad course. But if you look at a packet sniffer, you'll see those router solicitation messages, and they'll say, hey, I'm looking for a v6 address, or anybody with v6 addresses, and then the advertisement will come back and say, hey, yeah, I've got a v6 address, here it is. That node will reply with the address information. And then you have messaging between v6 devices. You have neighbor solicitation and neighbor advertisement, and that happens between these routers. So routers will say, okay, hey, I see you as a router over here, but what's your v6 information? I need to get that information from you. And then it will also have duplication address detection on there and saying, hey, wait a minute, I'm already seeing this v6 address in my area. What's going on with this? And you'll get those errors on that, and you'll have to go in and fix that. Now, when you test your verification, and this is a tool that you'll be using in this course, that's the ping command. And you can test your local stack or your local NIC card by using the 127.0.0.1 with v4, or you can ping : :1 for v6 at your local. You can test your connectivity to the local LAN. So you can say, okay, well, I'm 192.168.2. Well, I'm looking for .3 over here, 192.168.1.3. Can I ping that? That's a local. And then you can also test your connectivity to a remote. I have to say, if I can say that again, test your connectivity to a remote. And so what I would do is from here, I would ping 10.0.0.1, and it would route that through and says, okay, yeah, that's available for me. If it's available for me on there. If it's outside, it's probably, if it's outside your, if it goes out to the internet, it won't be. So if you have the internet in here, it won't be routable and it won't be testable. But if these routers are inside your organization, then it will pass it through. But if it goes out to the internet will not route that. You can also do trace route, which is test your path. So, you're going to be using trace route in this course, but you test it out. Trace route allows you to be able to say how many hops do you get there, your round trip time, and it also has that's your time to live in V4 and your hop limit in V6. And so it's going to say I'm trying to do a trace route from here. Let me erase all of this. So I'm going to do a trace route from here over to here. So what it's going to do is it's going to say, okay, here's my switch, here's my first hop, here's my next hop, hop, and then there, and it will give you all that information. It'll give you that connection information as it goes through. And if it times out, if it's too far, or if it doesn't get there, then it'll time out. But that's your trace route. Okay, so this has been Chapter 7. We have looked in Chapter 7 the use of V4 addresses, how that provides connectivity, V6 and how that provides connectivity, and we've also looked at some of the testing utilities, ICMP and the ping and the trace route, trace route and ping, and then ICMP, how that does broadcasting as well, to let the routers and the other nodes know that they're there. But we've looked at ping and trace route as well on network connectivity. All right, so I hope this video was helpful, and please leave comments below. I do appreciate that if you have any questions, or if you just want to say thank you, or if there's something that you want to see me do different, or if there's a point that you want me to clarify, you can leave that comment below too. Thank you, and I hope you have a great day.